even bigger protective layer, they put app domains around that and they just kill the entire domain just to make sure.
Perfect. Cool. Well, yeah, any questions on why we use garbage collecting? What the heck it's about? Yeah, cool. But basic idea, if somebody asks you, what is garbage collecting, Dallas? What would you say at a high level?
The garbage, well, I don't know if I could explain it at a high level, but the garbage collecting is basically the process of taking all these variables that get changed and no longer being used, tagging them as orphaned and sweeping them out so they don't clutter up all your space and take up your memory.
Perfect. That's exactly it. And then it repurposes that spot in memory to be used for something else later. That's garbage collecting. Nice. All right. So we're going back to this example here. We got name equals Austin, name equals Matt, var, great. This is horrible. Never do this. But if we refresh the page and let's do the exact same thing, let name equals Dallas. Okay. And now if I do let name equals Lehigh, what am I going to get?
An error. Name is already defined.
I'm guessing you get Lehigh, but I don't know.
Oh, didn't see that one.
That should not have happened.
I mean, since you're doing it globally, is it? Because it doesn't have a scope, right? So it's doing it globally.
So what that should be doing is that bit me in the rear. Is this should have actually thrown an error, because you can only have one variable name. When you say let name equals something and let name again, it should freak out. But you bring up a good point, Lehigh. Let me try this in a function scope. So we're going to go function test.
Try and break it on my local.
Yeah. Let name equal Dallas. Let name equal Lehigh. Console.log name. There we go. Okay, it blew up like it should have blown up. I don't know why it worked when it was in the global scope. I'm going to go figure that out after this.
So what would happen if you put let name equals Dallas, put that outside globally?
Outside of the function, yeah.
Would that still render Lehigh or?
Let's do it. So we're going to come here and we're going to say let name equal Tyler.
Yeah. And then take out, one of those.
All right.
I guess this is going to say
good.
Undefined.
So if I run, what's your guess? I haven't run it yet.
It's going to run. My guess is going to run Dallas because it's going to.
But if you run test, it's going to say Dallas. But I think if you just look for the name, the name, it would say Tyler.
Yep, name is Tyler. And test is Dallas. So that's good. So
that's similar to var. Yeah.
Yep, exactly. So var and let are function scoped. They're scoped to this right here within the word function. So they get trapped within here. They don't bleed out of it. But lets are also block scope. And I'll show you what block scope is. Let's see here. Oh, before I do that, let me show you this where we had that issue before. So we have function test again. And you guys remember hoisting?
Mm-hmm.
Basically console.log name. Let name equal Matt again. Console.log name. All right, what are we going to get here?
Error.
What kind of error?
Undefined.
Undefined isn't an error, actually.
Yeah, it's a type.
I'm going to divert to high school and say pass.
All right, let's run it. So what does that mean?
Is this kind of like what you explained? It's kind of like when you code is like when you drop a ball and it has to go down the code like in order.
Mhm.
So my guess, I'm not saying this is right, but first what it's doing the console log, looking for name. It hasn't been referenced, right? But then it goes down. I don't even know what I'm saying, but
Nope.
essentially,
I follow what you're saying. Is it just
if
then
you
the variable hasn't been named yet when you hit that first console log, and so that's where it's erroring.
yeah, so if you took out that first console log name, it would work, since let name has been defined before the console log.
Perfect. That's
So
right.
this is kind of interesting too. Just kind of looking up hoisting and stuff as we go through this, and it says that let and const are hoisted to the top of the block, but they're not initialized, just meaning the block of code is aware of the variable, but it still won't let you use it until
Yeah.
it's declared. That's kind of interesting. They know it exists, but they're still telling you no. So it's kind of like how Matt asked in the beginning, like, why is this feature a thing? When they came out with let and const, they're like, okay, it's not a thing anymore.
That's-
We're undoing the quote unquote feature.
Yes, exactly. Let and const were introduced to better match to what other programming languages do and to take out some of the magic or the quirks of JavaScript. Because, yeah, hoisting is cool, but what it really does is it causes way more problems than it does coolness. Your code should be very predictable and not do weird magic under the hood. Like, code is written for humans to understand, that is then transpiled down for the computer to use. It's not the other way around. You're not writing something for the computer, you're writing something for humans that the computer can eventually understand. So code should be very readable. You should be able to walk through it and your mind should be able to understand it. Hoisting went against that really, really bad, since it was magically moving your variables up to the top of their function blocks. And so they introduced let and const. So
is const still const that you can't change it anywhere once it's declared as a const?
perfect. Let's roll right into that.
Ooh, yeah, go into that. I have a semi off topic questions for later.
Okay. So first off, so with let, we have let name equals Dallas. And then if you say, all right, are you allowed to do this? Is this okay with lets? Is this okay?
Don't know.
Yeah, because you can change the value of let. It's just const that's going to bark at you.
Yes. Let's, you can change it. You can even change the type. You can say, I can come back in and say name is actually an array now, and it's okay with that. Or name is now an object. It's totally fine with that. Now, as this is kind of a setup for what's going to come next, if I say const name equals Tyler, now I want to set name equal to Matt. What do I get?
It's gonna throw an error because it's already been declared Tyler, and you can't change a const.
Yes. And it will actually throw you a nice error telling you exactly why you're wrong. Assignment to const variable. You can't do that.
It's a contradiction in terms.
You can't do it. Okay. What was your question on this one, Lehigh?
Oh, I already kind of tested it. And it didn't really matter. I was just kind of wondering, we had that problem with the the global scope for a let variable, and so I tried doing like var name equals whatever, and then let name equals whatever, but it still worked. Whatever. So I have a question.
Yeah.
That's related to const though. Can you define it after you initialize it?
Can you define it after? Oh, so you're saying, can you do this? Can you say,
Or declare it? Sorry, not initialize.
so I say const, const name like this.
Yep. And
No.
enter. Oh, I was just kind of curious.
So
I didn't know if it would just kind of lock it in after the first declaration, or nope, just doesn't work.
nope. So there is some gotchas with const. If the value is a primitive, you can't change it. Do you guys know what are the primitives for JavaScript?
Booleans, numbers, strings.
Yep. Yeah, Boolean you can do. Undefined is a primitive. Null is a primitive. But yeah, those. So what I mean by that, so if I come in here and I say const name equals 1, I can't change it to 2. Just can't. It's already defined. But there is a gotcha. If you use a non-primitive, such as an array, so we go const array equals an array, I am allowed to do this, right up, push. We'll put in here, Dallas. So whenever you say a constant, this is something that broke my brain a while ago, was I thought as soon as you say const and you gave it something, you weren't allowed to touch it ever again. Like you can reference it, but that's it. As soon as you do it as a non-primitive, such as an array, an object, a function, and I think you can probably do some more. You can change the contents of it, but you can't change its type. So right here, so do you know what I mean whenever I say that? You can't change its type?
Can't change an array into an object or into a string.
Yes, but just as long as it's a non-primitive, like, because if I have a string in there before, I can't put another string in there, even though string would be the same type.
Correct.
I'm assuming you also can't redeclare it, right? So right now you have array there. Can you do array equals and then do an array, even just another empty array?
No.
Right, so you can't redeclare it either.
Yes.
Even though it's the same type.
Perfect. Because so that let's a little bit deeper of what's happening here. Since it's an object or an array, have their own memory addresses of that. There's this little, it's a plot of land that is, I said, this is an array. This is great. Whenever I come in and I'm pushing values into that array, when I say Dallas or Tyler or Lehigh or whatever, those actually are different memory addresses. They're living somewhere else. They're not actually living in that same spot that we define the array. That array is just referencing those other spots of memory. And so with a constant only cares that it is not being redefined. It's not getting a new memory address. So as long as whatever it's holding isn't, and you can manipulate it to whatever you want, isn't going to change its actual memory, it's fine. So that's where an array and an object are okay, because whenever you're adding stuff to it, it's actually putting stuff into different spots in your computer's memory that are just referenced inside of the object or array. That make sense? Cool. Well, any questions about consts? Cool. All right. Now I'm going to show you guys some weird, really weird stuff. What more reasons why we don't want to use var, or we never want to use vars. Okay, so let's say we have let's see here. Do this from over here. So we're going to do a function, and we're going to call this, this is our test. And we are going to do a for loop for var, come on, for var I. People are watching, it's tough. As long as I is less than 10.
That's greater than.
Uh-huh. As long as I is less than 10, we're going to do I++.
Someone only uses .map.
What's that?
Said someone only uses .map anymore.
That's right. Okay.
Can't remember the last time I actually wrote a for loop.
All right. What we're going to do is we're going to do a set timeout. And I want to try something here. So in our set timeout, we're going to have it go for 1 second. And after 1 second, I want it just to console.log whatever I is. Okay. So nothing too crazy. In fact, I don't even, actually, this is fine. So does everyone understand what's happening here?
Yep.
Cool. I'm going to loop through this 10 times, and then it should console.log out whatever I is whenever it loops through. Okay, what is it going to be when I run test?
Guessing it'd be a 10.
Or 1.
Yeah, what 10 or 1, and how many times is it going to loop it out?
It's going to loop.
Gonna go 0 through 9.
Whatever it's at 1 second.
You know, I changed my answer. I think it's gonna be 9 because it's less than 10, but not 10. Oh no, never mind. I'm back at 10.
Back at 10. Okay. All right. So it logged out 10 times. Why?
Because you told it to.
Because I told it to. It's because whenever it's looping through here, the initial declaration of I, so var is trapped to the function block scope, which is right here. This curly brace to this curly brace. It's locked between there. So I is actually hoisted up to this level right here, right in between. So every single time it's looping through, the original var I is being updated. And so whenever this gets done after 1 second, it only knows what that value of I after it has finished looping through everything, which is 10. Because it's not creating a new version of I every time. It's using the same variable.
Could you help me with something? I hope I'm not cutting off.
There you go.
I remember doing this in the boot camp, but could you give me some like real life practicality of when and why you would use this?
Like this kind of loop here?
Yeah.
Yeah.
Loop map. Yeah.
Yeah. Sometimes you will do, I've run into something like this before whenever I'm doing promises, where I will try to come up with like a good example, but I will be looping through something and I need to make 10 requests off to a server for something. And that's a promise. So those won't be coming back immediately. They won't be executing sequentially. It will be, hey, whenever you get done and you come back to me, I will then process you. So I'm trying to come up with a good example. Like going out and saying like, hey, I want to go get, oh yeah, sure. Let's pretend like we're saying, call get people. Get people. And what we do is, let's say we have 10 people. So I say people equals, and then we'll have person A, person B, person C. That sounds good. Okay. And we want to know which one came back first. And so we're going to use their index of whenever we send off this request to say, go get me A and your position 1, go get B, your position 2, go get position C, your 3. So let's pretend we got I equals that. So we can go people dot length. And we're saying, okay, we're just going to use the I. We're going to use that for their index because we know, hey, the first time we loop through here, 0, that must mean this person. Next time we go through is 1, this person. Next time through is 2, that's this person.
Okay.
So pretend like set timeout is our HTTP request or our fetch. Whoops. Hit enter. And you say, hey, I'm going to send that request off. And I want to know when this person gets back. So I'm going to say console.log. I is back and I want to do people I like that. In fact, just like this. Okay. So theoretically that means, hey, I sent off a request and I want to hold on to what index I sent off. And I want it to log out to me which person came back by their index. Does that make sense?
Mm-hmm.
So if I run this, I get 10. I don't want it to give me 10. Sorry. Oh, get people. Three undefined. Whoopsies. Anyways, what that's supposed to do is that will actually get the person and it would log out C every time.
Okay.
Set timeout console log people.
So Austin, is this these for loops or map loop, like if I wanted to set up like a mail distribution list where I have these, JSON tables that have a person's name and their email address as a property, and then just have like a form letter, but want to generate it through and be like, okay, I'll go find this person's name with their matching email address and send that out and then keep going through. Is that the type of thing I'd use it for?
Yeah, something like that. This isn't something common you'll run into. This is actually pretty rare. In fact, if you're ever looping over and you're using the index to keep track of them, you're doing something kind of weird. This is just more of trying to show this is how this is working, but not very common. You'll do this. And if you really want to do this, let me show you the difference if you use let instead. I want to find out why this isn't working here. But anyways, so if we change this instead to let, what are we going to get?
Just 10, but not 10 times.
Just 10? Okay, let's give it a go.
Oh.
So anyone have an idea why I did that?
No, I don't.
No idea.
Okay. So the reason why it did this, because it's a special property of let and const. Vars, this is something important to remember. Var is function scope. Means it goes from the word function right here, from this curly brace to this curly brace. Lets and consts are block scope, which means they go from any curly brace, they're trapped. So since let I is more or less, it's defined between these curly braces, for loops with the parentheses right here is actually taking this and passing it into the curly braces, but whatever. So it's trapped between these two curly braces. So every single time this loops, it creates a new instance of I that is contained to this block scope. It's also function scope, means if I define it outside of test or right below test, it will get trapped between these curly braces. So this is really important. So this I that it's holding here, it's making a new memory address every single time it loops through. And just like Matt had said about garbage collection, it's not lost since we taking that I and we loop through and we're holding onto it here as a reference, it creates it and it holds it until this 1 second hits, and it references its original I value. And so that's why it comes through and says it knows it has its own 0, own 1, own 2, own 3, own 4. And then it loses, then it all gets garbage collected after this gets done running. This part's really important. Because yeah, this is why let and var, or let and const, you will always use those. Never use var. Because if you start using var in between these curly braces, like you saw I did before, it's going to give you weird results because it's actually hoisting it outside of these curly braces and it puts it up to the test level since it's function scoped. Cool. These are one of the things that whenever you get coding and something bites you in the butt, this is where you'll start digging into it and go, oh yeah, it's scoping. That's what's getting me.
Yeah, it's definitely tricky to think about. You might even, can you recreate the what happens with var with let?
Oh, do the same thing, but like how would you do it differently to make it work?
No. I'm saying use let and recreate the mess that var creates.
Oh, yeah.
I'm just wondering if that might help it make sense.
Yeah, let me try this. Actually, it's kind of an interesting idea. So what we can do here is instead of defining let I right here, we're going to do this. Let I equal 0 here.
Do you even need to have it equal 0, or can you just declare it?
I don't know. Let's try it. All right, here we go. Uh-oh. Oh, I got to run it.
You didn't run it. I was like, is he reading it? Yeah, there it is.
Cool.
Yeah,
Why-
so this is
why is
what
that?
the var is doing, is it's pulling up that variable to the top and then referencing it every time for inside the set timeout.
Yeah, so it uses this guy instead of creating a brand new one each time. I think
that makes sense. Thanks, Levi. That just made it click.
Yeah, and that's, as Austin was explaining it, it took me a while to like understand what he was saying, and so that's why I thought this might help as well.
Cool. I think you can actually go one step further. I think you can actually do equals 0 here. I think you can do,
Just say I.
I think you can do that. Yeah,
Yes.
cool.
Let's make our code completely unreadable.
This is turning into be super helpful.
That's like that meme. That is the worst code I've ever, or that's the worst working code I've ever seen. Ah, yes, but it does work.
Good. If you guys want to see a really horrendous way, if we go the other direction, how would you make var work the same way let was working? It looks not good. It looks like this. It looks like for var I equals, and we'll say, sure, 10. And you do, as long as I starts less than 10, let's put that back to 0. Do I plus plus. Okay. And now you're like, hey, I want it to log out 1 or 0 through 9. You do this fun thing. And bonus points if somebody knows what this type of function is called. As soon as I get done here, we're going to do X, set timeout, function.
Is this just an anonymous function?
Yes, but it's one thing more than that. This is a few anonymous functions, but It's mostly this parentheses, and I'm almost done writing it, and it should give you another hint. The log x. This is bonus points, but sometimes you'll see this on a test as well. And all right, what is
Oh.
that called?
It's in Efi.
Yeah, it's
Immediately invoked function
immediately
execution.
Yeah,
Good.
or self-invoking function too.
Yes, but if you call it immediately invoked, then you get to call it Efis.
Yeah. So
IIFE.
let's see if I blew that up or not.
You call them recursive functions.
This one isn't recursive because it's not calling itself repeatedly.
It's not calling itself from inside itself.
Yeah, it's just I think, yeah, the way Lehigh said it is probably more descriptive. It just, you made a function, this parentheses right here, and what you're doing is you're passing a value into this function that only this function has reference to.
You're right.
You don't
And-
see this very often anymore.
Well, and going back to what I said originally, it's anonymous because you're not naming it. Right. This function has no name. It's kind of like the orphaned variables, but it has no name and it can't be referenced anywhere else except inside here. And then it's immediately invoked or self-invoking because it just runs itself. It's never being called from anywhere else.
Yeah.
What's the purpose of it? Just the timeout, the asynchronous nature of it?
Yeah. So whenever you do parentheses like this, you are creating your own. You're creating its own scope, because remember how vars are
sure.
trapped to a function
Mhm.
scope, and so that's what these parentheses are doing. Is it's trapping it, and you're passing I into here, and it becomes available between these two parentheses, and so it creates its own instance of that variable.
It's kind of a way of creating private variables as well
Yeah.
because it has its own scope.
So really, the only time you'll ever see something as horrendous as this is on a test. This is horrible. If you get somebody on your team to submit code that has this in it, you look them in the eyes
I'll
and
slap
tell them,
them dead.
yeah, to reconsider their life choices. Yeah,
Why?
It don't work for me anymore. Get out of here.
yeah, you're done. And I mean, since we're beating this up, remember, it's just var let I equals 0, and as long as I is less than 10, do I plus plus, and you do your set timeout, and you give it a function, and we're going to use an arrow function, which we're probably not going to have time tonight to go over arrows. We only got 5 minutes left.
There's always time to go over arrows.
Always time. Also .log I. Significantly simpler and to the point. And I just did it to give me 491. That was weird. So do that. Okay. Since we are in our last 5 minutes, I just want to go ahead and review. So, all right, we're going to do this kind of quiz style. Tyler, what level scoping are vars?
var is a local and global scope.
Good. I'm looking for a keyword. Is it block level or function level?
It is function level.
Perfect. Good. Dallas, what is the difference between a let and const?
Const is immutable. It can't be changed. At least its primitives can't be changed, or its type can't be changed, but let can.
Yeah, good. Matt, what is hoisting?
Hoisting's grabbing all the variables that appear in a routine and shoving them to the top so the compiler doesn't have errors because you're a lazy bastard.
That's how you'll remember forever. Out of var, let, and const, which ones are hoisted?
All of them.
Yes. But which one gives you errors?
All of them.
That's right. Let and const will give you errors, and the compiler will tell you or the browser will tell you you're a dummy dumb. Var will let you slide by.
Let and const will give you errors right away. Var, the errors will come later.
They're the sneaky ones that come up behind you.
I'll give you errors. It's just a matter of when. It's almost like women.
Don't you worry. Okay. What with consts, what things can you change with them? Go for it. Anyone.
You could, well, it's the example you gave with the array. You can push things into a const into an array, but you can't change its type.
You can change the memory that it has allocated, but you cannot change the address to the memory it has allocated.
Yes, exactly. So for fun, Tyler, you brought up the array. That's perfect. Now let's look at an object equals this.
So you can change its properties.
Object dot name equals Bob. And that is okay. All right. Okay, those are the main things we wanted to cover tonight for Varlet and Const. Okay, opening this wide open. Any questions about what we talked about or anything JavaScript related or anything at all?
No, Austin, are you going to post this? I know you're recording. Are you going to post this anywhere?
Yes, I'm going to put this I will put it up on the YouTube channel. I'm going to have it private and share it out to you guys. You guys can use it, reference it however you'd like to. I will eventually make it public, probably after a few weeks, because this is a paid course. This is your guys' content. But yeah, that's where I'll be putting it.
I have one more question on const. Can you make a const array?
Can you make a const array? Oh, hey,
yeah,
look.
just real quick. If you may have,
other Matt is here.
Hi,
Yeah, other man.
hey buddy.
I've been lurking this whole time.
I know it's just kind of weird that you're on your bed sheets now. All right. Can you? I don't know if you can ever do this. Can you set array length?
Set array length? What do you mean?
No.
It's not like a settable field, right?
Oh,
Array dot length.
you can do this.
I mean, I know you can fill.
You can do something more than that.
I'll never forget fill.
I think you can do this. Let me try.
Just trying to find ways to break const. Nah, that's boring. Let's see.
You can do that.
Interesting.
Why you would do that?
I don't know. I never got, because I think it's Java. Like when you set an array length, it's set, and so I can understand that. But like in JavaScript, it doesn't matter. So yeah, I never got the point of doing it this way in JavaScript.
Yeah, this is an interesting way. If somebody thinks of a good example of why you would ever do what we just did, besides for like Java, whether you actually care about memory, I can't think of another reason to do that.
Jesus. You actually care about memory. You always care about memory.
I do care about memory. I'm sorry, but not really.
It's 2021. I don't care about memory, and you can't make me.
Yeah. Any other questions, Matt? Matt Lurker, Matt. What did you? Hey, you tell me the difference between Varlet and Const.
No, why'd you appear at the end? No, that's cool. So vars they're specifically function scope, sorry, and they can be used locally or globally. With const and let, well, I'll start with let. So a let you can basically declare and instantiate later if you want to, which something you can't do before. Or you can also basically change it to be whatever you want it to be whenever, doesn't matter. With const, you can change, well, okay, you can't change primitives. And if you assign it to be a type, you can't just change the type later on. So if you assign it to be an array, you can't say, no, I want it to be an object now. But you can change what's in the array or what's in the object whenever.
Perfect.
I have a question, Austin.
Mhm.
Is let and const different from each other in any way besides const being immutable? Because I always understood them that, hey, these are the same thing, except you can't change const, right? Outside that one big difference, are they just 100% the same?
Yes, they are.
Okay,
Const
that's
just
what I
has
thought.
Const just has an extra shield around it.
Right.
And this is a good question for everyone here. Why in the world would you ever use const? Why not just do let for everything?
There's some variables you don't want to change.
Honestly, you should use const as much as possible. Your default should be almost to use const, and then if you need to change your variable, you can kind of reconsider that standpoint. But by using const, you don't inadvertently change a variable that you don't mean to change.
Good. Good. Matt, what do you got for us? Other Matt, not you, Matt.
Oh, herpes simplex 10.
Yeah, what do you got?
Nothing. What do you mean? What do I got? For what?
Anything, because you've worked on teams before and other languages. Why would you use const versus let?
Oh, yeah, like you said, safety reasons. You have variables can often be, everybody has the same idea for a variable name. If you have a flag called Visa2 to know if the Visa2 protocol is being used, you might want to type it in first, see if somebody else has used that variable name.
Perfect.
So to declare it as a const, you don't got to worry about it.
Perfect. That's great. And going back to my original point, code is meant for humans, not meant for computers. Computer doesn't give a care about const, let, or var. It doesn't care. It's just different ways to allocate memory. Const is for the developers to stop them from unaccidentally shooting themselves in the foot.
Yeah, to go along with that, computers only do exactly what you tell them.
That's what I say.
Yeah.
So it's a brutal truth, but if it's not working, it's not the computer's fault, it's your fault.
That's my favorite thing that people do. But the computer was acting funny. No, it wasn't.
Yeah, exactly. And const just gives you that little bit of help to prevent you from doing the things that you're going to blame the computer for doing.
That's perfect. Okay, guys. Well, anything else before we have our final thought?
No.
Okay. All right. The final thought is last question. When should we use vars?
Never.
Never. Perfect. Well, cool. Well, thank you guys for coming. And I'll be scheduling our next class will be next week on Wednesday, same time. And I'll be coming up with the topics for that. And yeah, we'll see you guys then.
Cool. Thanks, Austin.
Thanks.
That's awesome.
See you, dudes.
See ya.
Bye.
Bye.